In this video, I'm going through the Arduino sketch that I put together to control the first group of turnouts on my N-scale model railroad using servos and an Arduino Nano. I'm going to go through the sketch explaining the logic behind the code. The code is available on my website by following the link in the description. So at the top of the sketch, I'm including the Servo library. That's key so that you can control the servos in the sketch. You may have to add the Servo library. To do that, you click on this icon and then search for Servo and click the install button. At the top of the sketch, I have constants declared for the number of servos I'm controlling and the number of switches being used. Note that in this case, I have a crossover that comprises of two turnouts, but just one switch controlling both turnouts. The next block of constants has the minimum angle of the servo and the max angle. This is what works for me in N scale. Larger scales may need a smaller min angle and a larger max angle, as the servo will need to move further in each direction to throw the turnout. I also included the throw minimum and maximum values. As the comment says, this corresponds to the switch positions, either 0 or 1. And finally, servo speed. I want my points on my turnouts to move slowly, just like on the prototype. So this is a 60 microsecond delay for the servo to move 1 degree. In the next section, I define constants for all of the servos. The abbreviations just mean something to me. FYL, for instance, is a float yard lead. FSL is the float storage lead, etc. I actually didn't end up using all of these constants in the sketch. I think the only ones that I used are the crossover servo ones. And then also I have a section for the switch names. Most correspond to the servos. Now to initialize some variables. I decided to use some arrays which are basically just a collection of indexed values. One for the servo definitions, one to hold the current servo position, and one to hold the pins that each switch is plugged into on the Nano. I also wrote the simple function that throws a turnout. It takes the index into the servo array and the throw direction of the servo. If the servo position matches the throw direction already, then we do nothing. Then, if the throw direction is the throw max value, 1 in my case, it moves the servo with the right command from the minimum angle to the max angle 1 degree at a time, waiting in between for the servo speed value, which is 60. To speed up the servo, you just change the servo speed value to a lower number and increase it if you want the servo to slow down and throw the point slower. And if the throw direction is throw min, that's what this else section handles, then we simply move this servo from the max angle value to the min angle value with the same delay. I also update the servo position in the array to the current throw direction. For the one-time setup when the sketch is run, I initialize all the switches by iterating through them all and setting the switch pins array to the index plus the number of servos. Basically on the Nano, I use the first 7 pins for the servos and then the next 6 pins for the switches. I'm then assigning the switch to the correct pin and use input underscore pullup so that I don't have to put resistors on all the switches. Now to initialize the servo positions based on the switch positions. This avoids having servos in the wrong position based on the switch position when you first power up the Nano. So I check what the switch is set to by reading the correct pin, and then depending on the position, I either set the servo to the min angle or the max angle. I then set the array with servo positions to the switch position, and then attach the servo. Attaching the servo last ensures that the servo doesn't default to center at boot up and then change to min or max. This reduces the times when the servo actually needs to move because usually the switch position and the servo position should match. However, for the crossover, we have to handle this in a special way since there is an extra servo we need to set the position for. Hence why the crossover servos are the last ones at the end. It makes the coding easier. And finally, let's have a look at the main loop. Basically all this does is iterate through the switches, checking what the switch is set to. For the crossover, we need to throw both switches. Since the turnouts are back to back, throwing them the same way works. If it's a regular turnout, then we just throw that servo, and in turn, the turnout is thrown based on the switch position. I realize some of this may have gone over your head, especially if you've had limited experience in writing code. The nice thing with this code is that you really only have to change the constants at the top, and the code below should work just fine. If you have any questions or want clarification on any of this that I went over, please leave a comment below and I'll respond. And if you want the code to be able to modify it to your own needs, grab a copy of it free from my website, link in the description. Thanks for watching.